Many FLL teams follow black lines or use the gyro sensor to drive straight, and usually these programs work well. However, in order to stop at a desired position, teams program the robot to exit their loop after the color sensor senses a color other than black and white, or after a touch sensor bumps into a wall or emission. The problem is, this requires teams to either be at the end of a black line or to be next to a wall or emission. The best solution for this problem is to exit the loop after the robot drives a certain distance. This way, teams can calculate the average rotations between each motor and stop when the average of the two motors reaches a desired value.
So the first thing you're going to drag up is a variable block, and you're going to keep it at its default setting as right numeric. If you've never dealt with a variable block, it's like any variable in math. You're basically storing some sort of value, such as a text or a number, inside this block. Next, we're going to label this block as average motor rotation. So in this program, after we find the average rotation in each motor, we're going to store it inside this block. Next, we're going to need a loop block, and then we're going to set this loop as logic, because after we found a desired motor rotation, we want to exit the loop. And then in order to measure the rotation of each motor, we're going to drag out a motor rotation block, set them to your corresponding ports, and change them to measure rotation. Now, in order to find the average rotations between motor B and C, we're going to add them up and then divide them by 2. So since we need 2 math operations, we're going to drag out 2 math blocks. Keep the first one as addition and then put the second one as divide. Then plug in B and C into the addition block. And then take the result of the divide by 2. Since we've now calculated the average between the two motors, we can now store this value into the variable that we created earlier as average motor rotation. Now the last thing you can do, if you want, is to display the average that we've just found onto the brick screen. We're going to have to read numeric because we've already set the value of the average motor rotation, and then drag out a display block, set as text pixels, and then set as wire because we're going to plug the result of the average block into this block. Now we can select everything and turn this into a My Block. So you go to Tools, My Block Builder, create a name or a description, and then a preferred icon. The only thing that we need to do is to create a parameter and create this parameter as an output. So after you've created this into a My Block, we need to plug in the average of the two motors into the parameter that we made. Now we can use this My Block to exit out of any loop, such as a gyro following program. So currently this is set to unlimited, so it's going to drive straight forever. Now in order to exit it, we can drag out our My Block, drag out a compare block, and then change the loop to logic. So we can plug in the average as A, the compare block as greater than or equal to, and then put the result of the compare block into the loop. Now you can change the value of B to however many rotations you want your robot to drive. Since this is all inside the loop, it's going to be constantly measuring whether the average rotations of the two motors is greater than B, and if it is, then it's going to exit the loop. Now if your motors are inverted, meaning negative power would make your robot drive forward, you would only change the compare block to less than or equal to, then you would just input a negative number for B.